observing the effect of heating soil. Can you see water drops appearing on the inner walls near the mouth of the test tube? This is the water that was present in soil. It evaporated on heating. On coming in contact with the cool edge of the test tube, it condensed into water droplets. The water present in soil is called soil moisture. Moisture content of soil varies according to the type of soil and can be determined on the basis of certain factors. Let's observe a small activity. A 20 centimeter long PVC pipe with a 5 centimeter diameter is vertically placed in the soil. Next, 100 ml of water is carefully poured into the pipe. The time taken for all the water to seep into the soil is noted. On dividing the amount of water by the time taken for all the water to seep in, we get the percolation rate of the soil. In this case, the percolation rate of soil is 5 milliliters per minute. Percolation rate of a soil is defined as the rate at which the water enters and moves through the soil. The percolation rate of soil depends on the size and moves through the soil. The percolation rate of soil depends on the size of its particles. Bigger the particles, higher is the rate of percolation. Sandy soil has a very high percolation rate. While the percolation rate of clayey soil is very low. Loamy soil has a moderate percolation rate. The water that percolates into the soil is absorbed and retained by it. Plants and other living organisms in the soil use the water in the soil for survival. The amount of water the soil can retain is known as its water retaining capacity. A simple activity can determine a soil's water retaining capacity. Place a funnel over a glass beaker. Fold a filter paper and place it in the funnel. Now pour 50 grams of soil into the funnel. This soil is dry and devoid of soil moisture. Measure 100 ml of water and pour it drop by drop on the soil. Continue pouring the water till it starts trickling into the beaker. The initial amount of water in the beaker was 100 ml. The quantity of water now left in the beaker is 50 ml. The difference in the initial and final amount of water is the quantity of water retained by the soil. From this calculation, we can conclude that 50 grams of soil absorbed 50 milliliters of water. Hence, the percentage of water absorbed by 50 grams of soil is 100%. The water retaining capacity of soil depends on its composition. Sandy soil has high sand content and hence has a very low water retaining capacity. Clay soil, due to its high clay content, has a higher capacity to retain water. While loamy soil, due to its high humus and clay content, has a good water retaining capacity.